Kristen, what'd you get?
31.
Bingo. Why is it 31 degrees? Yee. It's vertical to the 31 across from it. Very good. Okay. How did you get angle 2? Did anyone get angle 2? There's actually 2 different ways you could do it. John, how'd you do it?
I added the 90 and 31 and I subtracted it from 180.
Excellent. So what'd you get here? 59 degrees. Very good. Did you guys hear what he did? He added the 90, which is this side over here, and the 31. All 3 of those angles form a straight line, so they must add up to 180. And he subtracted them from 180. It was like 121, right? Subtracted from 180, John?
Yeah.
And then it became 59 degrees? Perfect, okay? What about the measure of angle 3? Did anyone get the measure of angle 3? The measure of angle 3. Diana? 59. Very good. Why?
It's vertical to angle 2.
Yeah. It's vertical to angle 2. And what about angle 4? Alexis?
90.
It's 90. Why?
Vertical.
2?
Angle.
It's vertical to what? Vertical to?
3.
Nope. It's vertical to the 90, right?
Yeah.
It's vertical to the angle that's 90 degrees. Okay? We Gucci on the warm-up. Any questions? Ask now. Zach, you got a question?
Oh, no.
Okay, here we go. Chapter 5, Section 2, congruent polygons. Guys, the most important thing here is something called a congruence statement. So when you hear me talk about the congruence statement, make sure your ears pick up. You actually listen to that part, okay? All right, so congruent figures. 2 figures that have the same size and shape. We know about congruence, right? We've heard about congruence before. So when shapes are congruent, they have the same size and the same shape. All corresponding parts of one figure are congruent to the corresponding parts of the other figure. Underline the word all. There is no part of any figure that will not match up to another part of another figure. They're all going to match up. Everything's going to be congruent between the 2 triangles. In this case, it's a triangle. But we're going to be talking about different shapes. A, and how do you know? Kristen? Good. Angle A is congruent to angle F. Remember, each part of one triangle should have a corresponding part. What's the congruent angle to angle B? John?
E.
Excellent. Angle E. What about angle C? Diana?
Angle D.
Angle D. Perfect. Okay. What about the side AB? What's the congruent side to AB? Yep. FE. Perfect. What about BC? ED. And AC? FD. So do you guys see how each piece of this triangle has a corresponding part in the other triangle? That's the main concept of today. We have to identify what's congruent between the 2 figures, okay? So these 2 triangles are congruent. Let's identify all of the angles that are congruent. So what angles in ABC are congruent to which angles in DEF? Kristen, give me one of them.
A is congruent.
Angle A is congruent to angle D. Okay? Another one. Another one. Who is that? Angle B is congruent to angle E. Perfect. And the last one, Marcus. Just kidding. Byron. BC is congruent to EF. Yes, but that's a side. We're talking about the angles. Do you know the last angle? Yes, angle C is congruent to angle F. What about the sides? What about the sides? Which sides are congruent to each other? Carson? CB is congruent to DE. You say DE?
No, D. Yeah, CD to C to DE.
No. Try it again.
CB is congruent to FE.
Yes, FE. Do you see how this is the piece that matches up with this one, Carson?
I thought it was just like whatever, like, if they like, you see how they're like this, like, I don't know.
Oh, no. So this is actually the figure kind of like got reflected, right?
Yeah.
So that piece is actually reflected. It's over on the other side. I would just use those congruent symbols to match them up, okay? What else? Zach, give me one.
BA and
BA is congruent to ED. Very good. And the last one, Ava? Perfect. CA is congruent to DF. Okay. Notice the notation, people. All of these are what kind of geometric figure? Yeah. They're segments, okay? All of these were angles. The notation is crucial, okay? Now, the order here, when you're identifying parts, does not matter. But this guy down at the bottom, do you remember how I said, pay attention to that one word I was going to say? This is a congruence statement. And the order does matter down there, okay? So they're saying two triangles are congruent, and they're listing them with 3 letters, okay? Every time they list a letter, it must correspond to the same letter in the second part of the statement. So, do you guys see how in ABC they listed it A, B, and then C? What was the congruent angle to angle A? D. So since A is the first letter, D has to be the first letter of the other side. Do you guys see that? The congruent angle to angle B was what? E, right? And the congruent angle to angle C was F. So if it's in the first position, it has to be in the first position of the other triangle. Do you guys see that? I'm going to write one that's going to be wrong. So let's say we had triangle BCA is congruent to triangle DEF. Look at the first letter. It's B, correct? Does B match up with D? Does C match up with E? And does A match up with F? This is wrong. The order absolutely matters for a congruence statement, okay? Now, if you shift the order of one of them, like they did, BCA, do you guys see that? And you change the order of the other one, it's still congruent. It's a good congruence statement. But the order has to be perfect, okay? Yeah, Kristen.
What about for the congruence, the corresponding sides?
Yep.
Instead of FE, you put EF.
It doesn't matter, okay? The order up here doesn't matter because you're just talking about the segment. But when you write in a full congruence statement in regards to the triangles, then it absolutely matters, okay? Did you guys hear Kristen's question? She asked if the order mattered up here, like if we had to write EF up here. And the answer is no. You can write it whichever way that you want. But when you write the congruence statement, the order of the letters absolutely matters. Hannah.
What if you wrote like BCA is congruent to EF, EFB?
Yeah, that one works.
Okay,
Mhm.
so it's just based on like that. I didn't know if it was like based on a certain side.
Nope, you can start with it whichever letter, okay? But it needs the letters need to match up each way, okay? We Gucci? All right. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. We basically learned this yesterday. And the reason that this theorem is true is because all of the angles inside of a triangle add up to what? 180. So if you have the same two angles between two triangles, wouldn't that third angle naturally have to be the same thing? Right? Makes sense, John, right? Mm-hmm. Now, if you want to star this one, this is a theorem that needs to get memorized. You need to know what it is, and you need to know the name to name drop it on an exam. Okay? Here we go. And then the properties of congruent triangles also follow from the properties that we learned in chapter 2. The reflexive property of congruent triangles, in other words, a triangle must be congruent to itself. The symmetric, which means that you can reverse the order of the triangles, maintain congruence. And the transitive property of congruent triangles. So if ABC is congruent to DEF, DEF is congruent to JKL, we know that ABC must also be congruent to JKL. Any questions on the last two slides so far? All right, let's apply them. An acute triangle, we're going to fill in the blank with always, sometimes, or never. An acute triangle is blank congruent to an obtuse triangle. The answer is never. Now, I want to hear from you guys why. Why would you never have an acute triangle that's congruent to an obtuse triangle? John?
One is bigger than the other.
What do you mean?
Like the angle, like the
Good. What makes an obtuse triangle an obtuse triangle? What has to happen in that triangle? Cody? Yeah, an angle needs to be larger than 90. And what has to be true about an acute triangle? All the angles are less than 90. So will that one angle from the obtuse triangle ever match up with the acute one? So they cannot be congruent. Do you guys see that? Okay. A polygon is blank congruent to itself. Always. What's a polygon? I heard that question. What's a polygon? Yep.
A sided figure with enclosed sides.
Yeah, it's just any figure, okay? Any shape that you see, okay? But it must be a closed figure, so it can't be open, okay? A right triangle is blank congruent to another right triangle. A right triangle is blank congruent to another right triangle. You think always? Who said sometimes? You are correct, okay? It's sometimes. And to understand this one, I would like you to draw a picture, okay? So over on the right-hand side, I want you to draw an itty-bitty right triangle, and then I want you to draw a huge one. John, are both of those triangles right triangles?
yeah.
Are they congruent?
Yeah.
They are congruent? So what does it mean to be congruent, guys? What does it mean to be congruent? Same size and the same shape. I agree that they're the same shape. Do you guys agree with that?
Yeah.
But what are they lacking? The same size. Would any of those sides of the little one be the same size as the big one? No, so they're not congruent, okay? They have to be the same size and the same shape. You got it, John?
Yeah.
Okay. If triangle ABC is congruent to triangle XYZ, then angle A, is blank congruent to angle Y. Never is what we initially think the answer is. But what if I told you that ABC was an equiangular triangle? What does that mean? What does equiangular mean? All angles are the same. In other words, all angles are how many degrees? 60 degrees. So if both of these triangles were equiangular, wouldn't angle A still be congruent to angle Y? So what is the actual answer here? Sometimes, okay? Now, if I said the same congruence statement, but I said angle A is blank congruent to angle X, what are we going to put here? This is always, okay? Because there's no chance, since those two letters are written in the same position, angle A is the first letter, X is the first letter, those have to be congruent based on the congruence statement. Questions on this one? On 1 through 5? How we feeling? We Gucci? Here we go. Example 2. In the diagram, ABCD is congruent to FGHK. Guys, the most useful piece of information out of all of this is that congruence statement at the beginning. Underline it, circle it, whatever you need to do to stress the importance of this guy right up here, okay? Because that tells you exactly what parts are going to be congruent to each other. And it wants us to find the value of X as the first step, okay? So what I want you to do is highlight all the pieces of information in your diagram that include X. So I see a 3X plus 6, or minus 6, and I see a 4X plus 2Y. You guys cool with that? Mm-hmm. Which one should we start with in order to solve for X? Why the 3X? There's no Y, okay? Always start with the one that only has X, because you don't know, like you're going to be solving for two variables here. So solve for x first and then use that x to find out y. Cool beans? So 3x minus 6 is in relation to what? What is that representing? Kristen? The segment GF. Or highlight it or do whatever you want. It's that segment over there. Now, look at the congruence statement. What two letters represent G and F in the other figure? Yeah? A and B. Because they're the first two letters of that one, so they must be the first two letters of the other one. Find AB in the other figure. And just check yourself. Do those look to be the congruent parts of these two figures?
Yeah.
Absolutely. So what do I know about those two sides? They're equal to each other. So what's the equation I can set up to solve for x? Kristen? 9 equals 3x minus 6. Or 3x minus 6 equals 9. Either way. Let's solve it. How do I solve it? Someone walk me through it. Kristen, go for it.
1 plus 6 on both sides.
Yeah.
2 equals 13.
Yeah.
Divided by 3.
Yeah.
So
X
x equals 5.
equals 5. How we feel on that one? Are we good on x? Let's go. No? Who said no? You're good?
Yeah.
You sure?
Yes.
Ask me, guys. If we have questions, you better ask me. We're Gucci?
Yeah.
You sure? Okay, let's move on. Find the value of y. Okay, what do you guys think I need to do? Plug in x. Very good. So let's plug in x first. Let's plug them into here. And let's get something else. So we're going to get 4 times 5, which is 20, plus 2y. Okay, so this is what we're dealing with now. You guys cool with that? How did I get that? So I took the 5 from the x, right? And I plugged them in here. So I got 20, because 4 times 5 is 20, and then plus 2y. You cool with it now? Okay. Now we don't have x anymore. We just have y. But we need to set something up to solve for y. What can I set up to solve for y, guys? What can I set up to solve for y? Hannah? Ooh, whatever the length of AD. Well, actually, what is this piece pointing to?
Okay.
An angle. How did you know it was an angle? Sienna? Good. Look at the angle that it's pointing to. It's pointing to angle what? K, right? What's the congruent angle to angle K?
44.
D, right? Because look, K is which letter? The last one, correct?
Yeah.
What's the last one in the other figure? D. So we know that those two angles must match up. So we can set 20 plus 2y, like Sienna said, equal to what? 44. So 20 plus 2y equals 44. You guys with me or not?
Yeah.
Yeah, a little bit. Any questions on how I set this one up? We're Gucci? Okay. How do I solve this? Someone solve it for me. Yeah, go ahead.
Subtract over the 20,
Yeah.
then divide by 2.
Yep. 2y equals, well, where do we get here first? I think it's 24, right? And then divide by 2. And what's my answer? 12 equals 12. Very good. Does that make sense to everyone? Speak up if it doesn't. We're Gucci? Man, I've been saying that a lot. I say it a lot. You'll get used to it. Yeah, Sophia. Why didn't I use 80? Great question, Sophia. Why didn't I use 80? I'm going to open that up to the class. Why is 80 not used? Good, it's for angle A. What is the corresponding angle to angle A, guys? F. First letter with first letter. Do you see that, Sophia? We were given nothing about angle F. Do you see that? It's missing. There's a big question mark here. Okay? But what we were given information on was angle K. Does that make sense, Sophia? All right. Write a congruent statement in another way. Go. Write it on your own. Go, 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 go. Make sure all parts are written down. Change the order up a little bit. Make sure it matches up. Okay. I wrote DCBA is congruent to KHGF. In other words, instead of writing it left to right, I just reversed the order, but I reversed the order for both of them. So I wrote it starting with the last letter all the way back to the first one. How many people did this on theirs? Okay. I would say if you're given a question, you're asked to write your own, this is probably the easiest way to do it, okay? Now, you have to be very careful and check what you did. If you started, for example, with B, right? If I say that my figure is B, A, C, D, I would get this question wrong. Does anyone know why? John?
You have to go like around.
Good. If I go to B to A to C, what happens?
That doesn't make
I've gone through my figure. This is a big no-no, okay? So check what you did and make sure you go around the polygon, okay? Yes?
I did BADC.
BADC, that is correct, okay? So BADC would work, but then you would have to do GFKH.
Yeah, that's right.
Nice, okay? Make sure your order matters in the congruence statement. Reagan, we Gucci? All right. We're going to do example 3 and then we'll be done, okay? All right. Maggie took the piece of fabric, STUV, shown in the diagram, and cut it on the diagonal to make a scarf for her and a friend. Are the two pieces the same size and the same shape? Explain. So if she's cutting it along that diagonal, what two shapes do I now have? John? Two triangles, okay? Now, sometimes it's hard to see, so I want you guys to trace the triangles in different colors. I'm going to do this top one in blue. And this bottom one I'll do in red. Now, are the two pieces the same size and the same shape? Well, what figures are the same size and the same shape? What kind of figures are the same size and the same shape? One? Congruent triangles. So we need to make sure that these are congruent. And in order to prove that they're congruent, we need to make sure that every single piece of one triangle matches up with a piece of the other one. Do you guys agree with that? So let's start with the sides. Let's start with the sides. So pick any side from the blue triangle and let's match it up to a side in the red one. Pick any side in the blue triangle and let's match it up with a side in the red one. Cody. ST is congruent to what? What's that? VU. Let's do it again, because we need 3 sides that are congruent. What's another side in the blue that matches up with a side in the red? John.
SV and TU.
SV and TU, very good. SV is congruent to TU. The last one, Kristen? Excellent. SU is congruent to SU. Why? Because what? It's the same thing, right? What property says that a segment is congruent to itself? Oh, come on. Yeah. Reflexive property. Very good, Marcus. Okay? The reflexive property. So, SU needs to be congruent to itself. Guys, anytime two figures share a side, that segment's going to be congruent to itself. Okay? And it's going to help you prove congruence. Are we Gucci on that? Okay. So we proved 3 sides. What else do I need to prove that is congruent? So shapes have sides and angles. So I need all of the angles to be proved congruent. Which angles are congruent in these 2 figures? Sophia? 2 and 3. Haha. Very good. Okay. Why is angle 2 from the blue triangle congruent to angle 3 from the red triangle? Cody? Very good. They're alternate interior angles, right? Because you guys agree these 2 lines are technically parallel since it's a rectangle. Okay? So 2 and 3 must be congruent by alternate interior. All right, what other 2 angles are congruent? What other 2 angles are congruent? John?
Oh, shoot. 1 and 3. No. I mean 1 and 4.
1 and 4. So angle 4 from the blue triangle is congruent to angle 1 in the red triangle. Okay, very good. They're also alternate interior. Do you guys agree? And what's the last congruent angle? What's the last congruent angle? Hannah? The 90s. So I can say which two angles are congruent, Hannah? STU, yeah, that's one of them, is congruent to SVU. You could have also just said angle T is congruent to angle U, or V, excuse me. Angle T is congruent to angle V. That's what you were trying to say. Okay, now, angle S and angle U do not exist, people. Don't label anything angle S or angle U because there's like too much going on at those points. Do you guys see that? There's more than one angle that occurs at this mark, right? At that point. So do not say angle S and angle U. Those are not angles, okay? Lastly, we need to write a congruence statement, okay? To say that the two triangles are congruent. So let's write our triangle for the blue. And let's use our three letters, S, T, and U. Do you guys agree those three letters create the blue triangle? Now, organize them so that the red letters match up with the blue one. What do you think the order of the letters needs to be for the red triangle? Kristen? U, V, and S. Now, a lot of students get confused because they think, wait, but S is in both. Shouldn't that be the same point? But it's different points for both of the triangles. Do you guys see that? Because the angle at S in the blue triangle is angle 2. And that angle matched up with angle 3 from the red one. So U and S are the corresponding parts of each of those respective triangles, okay? So those letters need to be in the same positions. This was a toughie, okay? All right, go ahead. Once you're done, the last slide, write down the answers to both of those questions and then turn these in. I'll give you 1 minute to do that. Guys, go ahead and go down to example 4. Cross it out.